So example 3, evaluate integral of x squared cosine x d of x. In this example, we will choose dv is equal cosine x d of x, and we will choose u is equal x squared. So from dv we find that v is equal sine x because we integrate cosine x d of x. This will give us sine x. And here we have u is equal x squared, that means du is equal to x d of x. Now the integral of x squared cosine x d of x will be u multiplied by v, so this will be u multiplied by v, x squared multiplied by sine x minus v multiplied by du, which is minus 2 integral of x sine x d of x. Now for integral of x sine x d of x, we need to use also again the integral by parts. So here we'll choose dv is equal sine x, we'll choose u is equal x. So for dv is equal sine x d of x, so d of x here is missing. So that means v is equal minus cosine x. The integration of sine x will be minus cosine x. For u is equal x, that means du is equal d of x. Now the integral of x squared cosine x d of x squared sine x will be the same. Now integration of x sine x d of x, it will be u multiplied by v, so this minus 2 is a constant, so u multiplied by v will be minus x cosine x minus integral of v du, which is minus cosine x d of x, minus with minus will be plus, integral of cosine x will be sine x, and here we have minus 2, so minus 2 multiplied by integral of cosine x, this will be minus 2 sine x. Now the integral of x squared cosine x d of x, this will give us x squared sine x plus 2x cosine x minus 2 sine x plus the constant c. We see this one is an application of the successive integration because it is of the form bx cosine kx d of x, where bx here is equal x squared and cosine kx is cosine x. We use integration by part twice to get this result. Also, there is another way to solve integration by part or successive integration by using this method, which is called tabular integration. So first we will choose here u, we will choose here dv. For u, we choose the function which is, once you integrate after many times, you will get 0. So the first function we integrate, we get it is 0. We differentiate, we get it is 0, it is x squared. And the function that we can integrate it more than one times, which is easy to integrate, which is cosine x d of x. So u is equal x squared, dv is equal cosine x d of x. Derivative of x squared will be 2x. Derivative of 2x will be 2. Derivative of 2 will be 0. So once we find the derivative of u, we'll stop at 0. Now we should to integrate dv. So the integral of cosine x will be sine x. Now the integral of sine x will be minus cosine x. The integral of minus cosine x will be minus sine x. So to solve integral of x squared cosine x d of x using this one, we will choose the first one from u multiplied by the second one from dv. Then the second one multiplied by the third one multiplied by the fourth one, and so on until we reach the final one is 0. We will take this one and multiply it by positive, then negative, then positive. Here the order is important. You cannot start by negative, then positive, then negative. No, you have to start with positive, then negative, then positive, and so on until you will get the last one is 0. So now x squared multiplied by sine x multiplied by plus 1, this will give us x squared sine x. 2x multiplied by minus cosine x multiplied by minus 1, it is 2x cosine x. And 2 multiplied by minus sine x, this will give us minus 2 sine x. Then you have to add the constant c. يعني في هذه الطريقة لما نجيب التابولر اللي هي بالانتجريشن دايما نختار اليو اللي كل ما اشتقها أكثر من مرة آخر شيء يطلع لي الناتج 0. يعني مثلا لو أنا بدلت أخذت إن اليو كوزين إكس، لاحظ إن مشتقتها ماينس ساين إكس، مشتقتها مرة ثانية ماينس كوزين إكس، وهكذا. ببدل بين ساين إكس كوزين إكس أبدا ما بوصل لي الزيرو. لكن بينما لو أخذت اليو إكس سكوير، لاحظ إن المشتقة الثانية 2 إكس، الثالثة 2، الرابعة على طول 0. بوقف عند الزيرو، إذا نختار اليو اللي هي إكس سكوير. الثانية بتكون دي في اللي هي الكوزين الإكس. لما نسوي لها انتجريشن بحصل ساين إكس، بعدين ماينس كوزين إكس، بعدين ماينس ساين إكس. لما أجي أكتب الانتجريشن of x square cosine x باخذ أول واحدة من اليو مع ثاني واحدة من الدي في، مش الأولى مع الأولى، لأ، الأولى مع الثانية، الثانية مع الثالثة، والثالثة مع الرابعة، وهكذا. أول واحدة بضربها في موجب واحد، الثانية في سالب واحد، الثالثة في موجب واحد. طبعا هنا الترتيب مهم، يعني لازم بلس ماينس بلس ماينس بلس ماينس وهكذا، ما يصير أبدأ من الماينس بعدين بلس، لا، دائما نبدأ أول شيء بلس ماينس بلس ماينس وهكذا. If you see that, if you compare this one with this one, it will be the same result. Then we have integral of x squared exponential 5x d of x. Also, this one is a type of the successive integration. That means we need to use integration by parts more than one times. So here we choose that dv is equal exponential of 5x dx, u is equal x squared. From dv we get that v is equal 1 over 5 exponential 5x, and du is equal the derivative of x squared, which is 2x d of x. Now the integral of x squared exponential 5x d of x is given by u multiplied by v, so it will be x squared over 5 exponential 5x minus the integral of v multiplied by du, so it will be 2 over 5x exponential of 5x d of x. So now we need to find the integral of 2 over 5x exponential of 5x. So for this again we need to use the integration by part again. We choose dv again exponential of 5x dx, so v will be equal 1 over 5 exponential of 5x. We choose u is equal to over 5x, that means du is equal to over 5 d of x. Now using the integration by parts, so here we have integral of x squared exponential 5x dx. This part will remain the same, which is x squared over 5 exponential 5x minus. Now the integral of this one, we use the integration by part, u multiplied by v, so it will be 2 over 5x multiplied by 1 over 5 exponential 5x, which is this one, 2 over 25x exponential 5x minus integral of v multiplied by du, so it will be integral of 2 over 25 exponential 5x d of x. 2 over 25 is a constant, integral of exponential 5x will be 1 over 5 exponential 5x, so this one will be the same. For this one we take it negative, so minus 2 over 25x exponential 5x. Integral of this one we get 2 over 25 multiplied by 1 over 5 exponential 5x, it will be 2 over 125 exponential 5x, then we add the constant of integration. Or we can do it by this one again. So again here we choose u is equal x squared, dv is equal exponential of 5x. Derivative of x squared will be 2x, derivative of 2x will be 2, derivative of 2 will be 0. For this one, integral of exponential 5x will be 1 over 5 exponential 5x. Then the integral of 1 over 5 exponential 5x will be 1 over 25 exponential 5x. Integral of this one will be 1 over 1 over 125 exponential 5x. We choose the first one positive, then negative, then positive. So now the integral of x squared exponential of 5x d of x will be x squared multiplied by 1 over 5 exponential 5x, which is x squared over 5 exponential 5x. The second one we take it 2x multiplied by 1 over 25 exponential 5x multiplied by minus, we get minus 2 over 25x exponential 5x. This one multiplied by this, we take it positive, so it will be plus 2 over 125 exponential 5x. In the last step we add the constant c.